What's up, everyone? My name is Jason Turley. We're back with more pwnable.kr, which is a free online website where you can try to solve different reverse engineering and binary exploitation challenges. Last time we looked at BOF, the buffer overflow exploit, which is a very simple overwrite of a value on the stack, and that's how we got our flag. Today, we'll be looking at a challenge called flag. It's a reverse engineering task. All we need is the binary. There's no server we need to SSH into, or there's nothing we need to netcat connect into. We simply need to grab this link right here, right click, copy. If you see, I've already solved this challenge, and this is just going to be my walkthrough of how I did it and maybe some pitfalls that I ran into. So I'm in my little working directory. You can see that it's completely empty right now. So let's change that by downloading flag. Okay, that looks good. We do an ls, la, and add the h on the end. It makes the output in human readable or just easier to read format, especially for this size argument, the size variable essentially. So we see that it's 328,000 bytes. So kind of a beefy file, especially for just a ownable task like one of these. They're typically smaller, compact binaries, but we see that this is a pretty large file. At this stage, if you're new to reverse engineering, or maybe this is the first time you've ever really encountered it, you want to collect as much information you can about the file. So we know the name, we know the size, but we don't know what kind of file this is. Is this an executable? Is it an executable that's very specific to Windows, like the PE format that can only be run on the Windows operating system? Or is it something else? Like in this case, we see it's ELF, ELF. I believe that's executable in linkable format. Let me just double check. ELF format. I don't want to give you the wrong information. Yeah, executable in linkable format. It's a standard binary format operating systems such as Linux. Cool. So we know what we're working with. We see that it is written in x86-64, so it's a 64-bit binary as opposed to a 32-bit binary. We see here that it's statically linked, meaning all the library code like libc is contained within this binary, which probably makes sense as to why it is so big with the 328,000 bytes, because all the library code is packed inside. If it wasn't, you would see dynamically linked here, meaning the code is supposed to exist on your operating system, and the binary just pulls the different libraries, DLL, shared objects, what have you, as it runs. No section header, so debugging it will be a bit more difficult. So we know a little bit about the file. Let's actually make it executable, and let's try to run it. I will malloc and stir copy the flag there. Take it. All right, not very helpful. It doesn't really tell us anything. We see two C library functions, malloc, memory allocate, whereas stir copy, string copy. So allocate some memory on the heap for us, and then copy that flag, I guess, to a different variable. But it doesn't actually print out the flag. If I try to grab this, copy, paste, and submit it here, it's not going to work. It's not going to be the thing that we're looking for. So one thing that we have not done yet, we have not checked out the strings, the ASCII strings, things that are human readable in this file. So we see the very first line. Let me zoom in just so that's nice and clear. We see UPX, and that really stuck out to me. If you're not familiar, UPX, it's terrible for me. I'll clean this up. So let's open up UPX, man, UPX. UPX is the ultimate packer for executables. We can use it to compress or decompress different executables, different binaries, and it just makes the actual binary smaller. This is useful if you're trying to download something and it's a huge file, it'll take longer to download, so you compress it and make it smaller so it will download quicker. Malware creators, malware authors also use this technique of compression to try to bypass antivirus signatures and antivirus detection. So That's cool. We'll make a mental note of that, but we'll come back to it in a second. Let's go back to our other pane in tmux where we have the output of the strings. And let's start perusing through. I'm just hitting the space bar, scrolling down. Looks like a bunch of junk. We don't really see anything useful yet. This was a huge file, so there is going to be a lot of nonsense, a lot of garbage. It did not look like it had any actual debugging symbols in there. Let's keep scrolling. We're not only looking through the actual, I guess, flag CTF functions that we care about, we're also looking through the contents of libc or whatever other shared objects or libraries were statically linked inside of here. Keep going, keep going. Okay, here we can start seeing actual words, actual English letters and characters that we understand. We see x86-64, so the actual binary architecture. We see arch, we see the word happen. Okay, we see debug, so we're starting to get probably into the actual contents that we would care about, right? Preload, all right, maybe something to do with the loader or the linker. Some more garbage, a lot of nines. I'm not sure what the significance of the letter 9 is in this binary in this example. A lot of R's. R9. Okay. I promise you we're almost there. Okay, here we go. Sorry that took so long, but this is a huge binary essentially that we're digging through. So we see some function calls. We see protect, execute, protect, write, failed. So those are memory protections for permissions for executing and writing to this file. So something with that failed. What we're more curious about is this line right here. This file is packed with UPX that we saw is the ultimate packer for executables. So it can compress your binary, make it smaller. And then they have like the actual link to it and control click, if you wanted to visit this website. Yeah, that's the hint, I guess. That's the spoiler that this is packed with UPX, and that's why we're not really seeing anything useful. That's why we're seeing a lot of garbage. So what can we do here? So if I go back over to the man page for UPX, we can scroll down, we can skip past the abstract, we can skip past the disclaimer. Right here, the description, UPX is a versatile executable packer with the following features. It's great for zip and gzip type of files. It's very fast, yada, yada, yada. So we keep scrolling down here. We can see the different commands, the different arguments, and the different syntax it uses. So by default, UPX will compress your binary if you just say UPX in the name of your binary or your executable. But you can also decompress it with the tech D switch. So UPX tech D and then the file. And if you're not sure whether or not it was actually packed with UPX, you can use tech T to test it or tech L to print out some useful information in case the file was actually packed with UPX. So let's play around with some of this. We do ls. Let's remind ourselves about the file size. We see right here, 328K. If I do UPX tech T to test, we get tested one file K. And if I wanted to do this again, but this time specifying tag L, that lists out this useful information. We can see the current size of the binary, and we can see what it will be once we actually decompress it, and the name. So let's do this, UPX tag D, and the name of our binary, smash the enter key, and unpack one file. If I do ls, it looks like nothing has changed. That's because it does the unpacking in place, meaning it just overwrites the actual contents of this file. Forgive me, I've been using my terminology a bit backwards. So the file was compressed, it was small. If you scroll up here, you see it's 328K. We decompressed it, so now it's even larger. It's 864K. So you might be saying, Jason, why did you do that? What was the point? The binary was already kind of tricky to reverse engineer, and you made it over twice the size. You made it even larger, even bigger. Well, look what happens when we run the file command. It's different. The output is different. We still know it's an ELF 64-bit binary. That hasn't changed. It's still statically linked. All the library code is still there. But look over here. We get the build number. I don't really care about that. But at the end, we see that it's not stripped, meaning it has all the useful debugging information. It might have strings that weren't there before. So let me rerun that strings command. Now when we hit enter, output is a little bit different. At the top, we don't see UPX anymore, that header, because it's no longer packed with UPX. This is the actual raw binary as it was developed. Smashing the page down key, see that this is a bit different. Still not very useful. Promise we'll get there eventually. Okay, there we go. Flew by it. So if I go up just a little bit more, we didn't see any of this before. You have to scroll down pretty far to get to this point. I might cut it in post-processing. But we see this. UPX sounds like a delivery service. Playing on words of UPS, the US Postal System, UPS, whatever it stands for. So that could be the flag. That's interesting. I will malloc and stir copy the flag. There, take it. That's new, or that's not new. We saw that before, right? We saw that when we actually made this executable, ran it. So we know that's there. We see these file system commands. We see these devices, dev random, dev full, dev null. Cannot set f-base address for this thread. We see a lot more information. We see backtrace, we see memory dump, so on and so forth. We see malloc.c. We see all these different files in function calls that we did not see before when the binary was compressed. Right, we see buffer overflow detected. So maybe it has some type of stack canaries or some type of protection warning if I was compiled. So we have a hint, we have a inclination, I guess, that the flag might be this. EPX sounds like a delivery service, but just to be sure, let's actually debug this. As we haven't really done any real reverse engineering, all we've done was look at the strings. Let's open this up in GDB. Tap Q to quiet so it doesn't give me all that header information. It still whines and complains that no debugging symbols are found. That's okay. You can still disassemble it with main. And just to I guess, beat it at horse. If I re-download that file, save it as flag original, lsf, lah. All right, so flag original, this is the compressed one. If I try to run this in GDB, cannot find the main function. Whereas here, it can disassemble main just fine. So that's the difference. Let me clean this up. So we have the main function. We see the stack is being set up, the base pointer being pushed and saved. We see this value right here is being loaded into the register EDI, and then put string is being pulled. So if you're not super familiar with that function puts, it's basically just going to print a screen, print a string. So puts hello world, right? Or you can just do man puts. And you see that it takes one argument up here. So that's how we know whatever this is a string. It's the string that's being pushed on the stack. Or I'm sorry, it's a string that's being moved into the register. It's the argument, right? This is what put string will actually print out and display to us. So we don't even have to run this. We can just grab this value, examine a string in GDB. I will malloc and stir copy the flag. Take it. We saw that before when we ran this binary, so that's not anything special. The value of OX64 is moved into EDI and then called with malloc. So malloc is going to allocate OX64 bytes, whatever that is in decimal. It's going to allocate that number of bytes on the heap. It's going to move some things, some other registers. We see 1, 2, 3, 4, 5 move instructions, and then we see call this function. We don't know the name of this function. We don't know exactly what it's doing. So we can set a breakpoint on this line after the function is called. And then we can examine EAX or RAX. That's the accumulator register or the return value register. So after this function is called, whatever result it has, it'll be saved in RAX/EAX. And we can just look at that. So let's do break star main plus 54. Hit run. It prints out the value that we saw before, and we get our breakpoint. If we run disassemble, we see this little arrow right here that points to the line that we're currently on. I can do IR, list all registers and the contents, and you see this value right here. We can examine it like this, RAX, specifying the $sign, same for EAX, yep. Or we can just slam in that value directly, and we all get the same thing. So that's one way you can kind of confirm that this is probably the string. This is the thing that they wanted us to find. So you can grab that back here, throw it in, and I already solved this challenge, but just to confirm that this is the correct flag, there you go. So that was a fun challenge. Just to like a quick little recap, the binary that we downloaded from here, the website, it is compressed, it is packed, it is not the raw original binary that the developers created. It's something smaller, maybe to bypass some type of antivirus. So if you ever do any type of malware or reverse engineering, this is a tactic that you will see quite often. So what we did is we decompressed it and we made it expand itself, right? And so we could see all the different function calls and whatnot. And it was a lot easier to debug. It was a lot easier to look at the ASCII strings. And we got lucky. There wasn't really a whole lot we had to do. We could just disassemble the main function and print out the strings like that. So there you have it. I had fun with this challenge. Before I decompressed it with UPX, as I said, I would talk about the pitfalls. Before I did that, just playing around, I opened it up in Ghidra. I opened up the raw original flag value, and it was a mess. It was compressed, and I really couldn't tell what was going on. And, you know, banged my head against the wall for a bit and kind of gave up. But once I actually looked at the strings and thought critically about what's going on, I saw that UPX header. Okay, Ghidra's going to complain, but that's okay. So the video is essentially over, but I'm just going to make this, I guess, just for the extra credit, just for the bonus material. Stick around if you want. So this is what happens when you open up the binary in Ghidra, which is a very popular reverse engineering framework. It's free, it's open source, it's provided to us courtesy of the National Security Agency of all people. I don't want open, I want import file. The original flag. Let's open this up in Ghidra. Sounds good. We haven't analyzed it, so let's analyze it now. I just like leaving all this stuff set by default. You see ASCII strings. We looked at that manually with the strings command. So, analyze. It tells us stuff that we already knew about like, the architecture and the file size. And I don't know if it actually says whether or not it's packed. I don't think that's in this output right here. But this is not a bad tab to have open, bad result summary. Okay. So this is where I was eventually, or originally. I opened up in Ghidra. I'm kind of just poking around. I believe this is the main function right here, entry. So if I click on this, you see this pop up. Extra out underscore variable. And this is kind of where I got a little bit sidetracked, a little bit confused, not really 100% sure what's going on. My Ghidra knowledge, my Ghidra usability is nowhere near where it should be. I'm much more comfortable in tools like GDB than I am in Ghidra. But I know it's super popular, it's super useful. So if you guys want more Ghidra videos in the future, I will grind and figure out how to use it and make videos. But yeah, just poking around. We do see some canaries. I don't know if these are like stack canaries for like flow mitigation. They could be. Right now, maybe it's just been a long day, but yeah, looking at all this assembly, all these instructions, not very fun. Trying to find a quick way to like pull up the strings. There we go. So if I go to tools or window, if I go to window and then define strings, it will pull up some of the strings that it found. And if you look here, you can either put your mouse over it and it'll expand it. This file is packed with UPX, or if you click on it, it'll take you right here. So this could be one way. Maybe if I was more diligent and I actually looked at the strings and Ghidra, I would be more successful. So just another tool for the toolbox, another way to do it. I guess you would look at this, you would take the hint, okay, it's packed with UPX, let me decompress it, and then you would venture forth. So yeah, no need to save. So that's really it. Fun challenge, not too bad. We still have a lot to go. We have a lot to go for this topless bottle, and I'm excited. So thank you guys for watching. Let me know in the comments down below if you find this type of stuff useful, if you have more content like this, if you had any tips or tricks, things I could have done differently, let me know. As always, take it easy and see you guys in the next video.